Hey, hi everyone. This is our two-part blog and uh, blog and explanation series on NoSQL databases. So, as most of you are aware, databases are mainly of two types: SQL databases and NoSQL databases. SQL databases have been around for quite a while now, but ever since NoSQL databases uh, uh, were adopted in the industry in the late 2000s. They have now taken over and have become the norm when it comes to large scale databases. This is mainly due to the scalability that NoSQL databases offer compared to SQL databases. They are also much more efficient, and it's much more easy to code or program on these databases compared to SQL databases. Uh, Given the advantages that NoSQL databases possesses, we as a group wanted to explore this. So I have with me Bhavik, Kashish, Smith, and Shweta. Together, we have gone ahead and done a couple of mini projects which could help us set up NoSQL databases in two different data formats, and then went on to import data and then work on those data to perform some analytics. So first up, we have mongoDB, which we have used as our document database, and then we have Neo4j, which we have used uh, uh, to base our graph database on. Handing over to Kashish, who will walk us through the setup of mongoDB.
Okay, so we start with the MongoDB database. It's basically a NoSQL database that works on a JSON-like documents and has a option of having optional schemas. So the first part, we have set up the MongoDB Compass. It's basically an interactive tool that's used for querying and analyzing. So the first step is to set up a connection. So we have connected to a local host, which is having the port number of 27017. After that, the next step is to create the database and the collection. Database is specifically we have taken is a supermarket sales data set. So we have created a supermarket sales database, and collection is equivalent to a table in a SQL database. So we have created two different collections, as you can see. The first collection is the sales data, and if we go down to the next collection, that is so the next collection that we have is the customer rating, collection. Both these collections are then populated with the help of JSON files and or CSV files. So you can see that the first collection, that sales data, is populated with the information. Similarly, the second collection is populated with the information. The next part that we kind of explored is working in mongosh. Mongosh is basically a tool that is used for querying, and in order to do that, we also have some mechanisms to install it on a system. So I basically run these queries on the terminal, and you can see by simply running the mongosh command, we can enter the environment and we can use different queries in order to explore it. The first query is to find the branch and city to store having of the store having gross income greater than 40.20. So you can see this is how the query has given the output based upon the data in our data set. The next query is to find the average customer satisfaction rating in each branch. In this, we have used aggregation pipelines, aggregations, and group by in order to show the output. So you can see in the output, we are showing two main columns or fields. That is the name and the customer rating, sorry, the branch and the customer rating. Moving on to the next query, we have displayed all the customer names having the highest customer rating of 10. So again, we have used aggregation for this concept. Next, we will move on and Shweta will explain the aggregation pipeline.
Yeah. To start off with aggregation pipeline, it's a powerful tool that has performed complex data analysis, and it is also designed to provide flexibility and efficiency. First of all, in MongoDB, aggregation pipelines are not just performing the analysis, but it is particularly dealing with large data set, and it distributes the operations in a manner that it makes it easier for the faster and more efficiently execute the query. So to start off is the first query that we have highlighted here is displaying the branch and total orders from highest to lowest. So if you look at the screen, we have three categories here. The first stage is going to explain about the group by operation, and the next stage we have a sort, and then we have the project. So here we have three screens here. The first is input. The next middle screen is where we have all the queries written, and finally we have the outputs displayed on the rightmost corner. So that's how we are able to see the output subsequently in each and every stage in this uh, MongoDB compass. And moving on to the next query, we are going to display, yeah, moving on to the next query, it's just stage 3 here. Yeah. Displaying the total quantity sold in each product line from displaying it in a hierarchy of highest to lowest. So the first stage, again, we have performed some operation, and second, we have sorted the records, and finally, we are projecting the output. It's almost similar to the first query, and finally we have third query where we have explained the revenue generated from each product line. And again, we are using sum and the orders which are listed in the sort, descending order with the sort operation. And finally, we are limiting it to 3 records because we want to display the top 3 product lines. And we have the project query. And finally, we have top 3 customers with the maximum gross income. Here we have, in addition to the group by and project operations that we have seen earlier, we are using lookup in the first stage, which is going to do a join operation like in SQL. And finally, we have grouped the output and sorted it and projected the output. That's about pipeline. Moving on, we have PyMongo. So PyMongo is nothing but a driver that is used to connect MongoDB and Python. So initially we have created a collection, like we have created a cluster in MongoDB Atlas, and then using the Python driver, we are connected it to MongoDB. So we have the queries here. The hierarchy was importing the PyMongo libraries, and then connecting it to the PyMongo database, and creating a database collection first, and then inserting the data. And finally, we have done a couple of CRUD operations here, like inserting multiple records, converting, inserting multiple records, and updating a record, deleting a record, and also displaying the output that we have received. So these are the queries that you're seeing for that, updating the payment method, yes, and deleting a record. And subsequently, we have pasted the output for each and every query that we were seeing earlier. So that's about deleting a query and displaying a query. Yeah. Passing on to Kashish.
The next part that we have is visualization. So for that we have created a dashboard for our supermarket sales, and we have created 6 different visualization. The first one shows the average customer rating across the different stores. The next one is the bar chart that we have used to show that how the customer rating or the different so how the quantity sold for each product line is based on the customer type. And third one is the total revenue generated for each store. So in these visualization, we can see that how the data set is getting can be analyzed for different aspects of supermarket sales data set. Moving on to the next concept, that is sharding and cluster computing in MongoDB. So sharding is a very important concept that is used in MongoDB. Usually the SQL databases use the mechanism of scaling up, that is vertical scaling of database, whereas in MongoDB we have the concept of scaling out. So in order to implement this scaling out feature, we have used the concept we can use the concept of sharding, where the data is spread across multiple servers, and this can help in distributing the load and reducing the load on the required hardware resources. Three main parts are there: shards, mongos, and configuration servers. The next part is cluster computing. So in mongoDB, we have a tool that is called as Atlas, which can be used to deploy a cluster. By default, that cluster creates a replica set. That is, it creates three different servers, a single one that is a primary server and two secondary servers. As you can see in the image, this is creating and deploying the cluster. So we have created a cluster 0 in our system, which is having three different primary servers, as we can see further. Moving down, how we are creating a cluster and deploying it. For that, the first step that we do is we create a database user, and you can see we have created a user with the privilege of admin. The next step is setting up the IP address, where we have set the IP address in order to connect the mongoDB Atlas with any other tool or any other language. We need to use this particular IP address. And then the last step is creation of a sharded cluster. So basically, mongoDB creates a sharded cluster with three servers. As you can see in this image, there are three different servers, one a primary server and the two secondary servers, and you can see the spikes on this, which is basically showing the queries and the commands that we have run, and it is showing that how each query and command has been used in the system and the metrics of it. The next, moving on to the interesting insights in MongoDB. The first interesting insight that we saw was that in aggregation pipelines, we can actually preview our output in each stage, which is very useful for us to understand how our query is progressing and executing. The next step is visualization part, where we can perform visualization in the same system, that is the MongoDB Atlas, and we can create charts and dashboards. Whereas in RDBMS, the same functionality will require an additional tool for it, which can be done in the same place in MongoDB. The third interesting insight is horizontal scaling with the help of sharding, whereas in RDBMS, we observe that usually there is vertical scaling. The fourth part is that in this particular database, indexes can also be auto-generated. We do not need to explicitly define primary keys or candidate keys in our data set. If we do not define any identifier in our data set, it will auto-generate an ID field for our data set. The next part is PyMongo. PyMongo is a very important collection that help us to create a single document and insert it into that collection, whereas in RDBMS, we have to create a table before inserting the records. So basically, the MongoDB database is an optional schema database. We can have a schema or we cannot have a schema. In case we don't, it can generate a schema for us. Technical difficulty. The first difficulty we came across was that while using the CSV files for importing the data, there were some fields which were having some issues for while inserting. So for that, we preferred to use JSON file, which was found to be more compatible in MongoDB environment. The next technical difficulty was while making connection between Python and MongoDB using PyMongo. In that situation, we were finding that the versions of both the Python and MongoDB should be compatible, so that to build a appropriate connection. In case there is not, then there is a halt in connection, and we resolved it by upgrading the PyMongo, and we have also specified the command for it. Moving on to the next step. We are moving on to the next part, which is NoSQL databases.
Yeah. So coming to the other part, that is, we have used Neo4j, which is a graph database management system. So first, we downloaded and installed the Neo4j on our desktop. Then we created a new project for our assignment, that is homework 4. Then we imported the files into the import folder of that particular database. Here you can see we have imported the bike sales CSV file. After the file is imported into the folder, we have to load that CSV file into our Neo4j database. So we write down the code for that and imported the CSV file into the database. So after loading the CSV file, this is what our graph database looks like. On the right side, you can see that there are various nodes like person, name, marital status, gender, etc. And below that, there are the relationship types, which connects all the nodes with each other. If we zoom in a little bit, we get to know that the center node, which is the person node, it is connected with the rest of the nodes through various relationships. So we get to know that how each nodes are connected with each other and how the various relationships are scattered amongst them. So after successfully uploading and importing the CSV file, we sat down and write down queries to get a few insights about our dataset. So firstly, we wrote down a query to get the most common distance that the bikers usually travel, and we also found out the frequency of that bikers. Here we can see that the most common commuting distance is 5 miles, and the number of bikers that are corresponding to that distance is 1110. The next thing we found out was we classified the group of the bikers according to their ages, and displayed the count for each of those bikers. Can you scroll down? So we classified the bikers accordingly. So we made a group with 18 years, people with less than 18 years, between 18 to 24 and 25 to 34, and we got the corresponding frequency of the bikers falling into that particular set of category. Other thing we analyzed was the persons who have a car and yet still they bought the bike. So and also their education and occupation. So we get to know that the bachelors in the manual occupation has the least number of bikes. So if we can focus on that particular set of category, we can improve the bike sales for those particular set of people. Then we found out the male versus female ratio for the bike purchasers, and we saw that we verified the marital status of the bike purchasers. So we get to know that married people hold up holds up to a 42% of total bike purchasers, while single people holds up to 54% of total bike purchasers. Then we classified the bikers depending on their education and occupation. Lastly, we found out the commute distance of the persons who neither have a car nor a bike, and yet they commute on a daily basis, and those are the counts for that set of people.
So we have also done some containerization using Docker. So it is a better idea to do the containerization if we have larger data sets, and if we apply containerization, then we can easily handle heavy workload. So to apply this step, we have used Docker, and to install Docker, we have to have first Windows subsystem for Linux, and the version of that file manager package has to be second. So here we can see that it is enabled and the version is 2. So moving on to the Chocolatey package, which is basically a manager package that can be useful for installing Kubernetes, Helm, and Minikube, which is also a tool for connecting Docker with our local host. So here we can see that in this CMD, I have given our pod name as the DBMS HW bikes, and that is our release name, and that will be our pod name. We can see in next picture. So as you can see that we have created the DBMS bikes as a pod, and this is implemented only in CMD. And after applying command name minikube dashboard, we can see that Kubernetes in our Chrome, and you can see that this is green circle. It shows that workload is not that high because the data set is not that big enough, but it's good to visualize that we can increase our data set as per our need. So moving on to the configuration mapping, this configuration map allows us to store key value pairs. As you can see that in that picture, the value is stored as a key and as well as pair as a true, false, and all the stuff. And this Docker dashboard also shows us that we have created a successfully container as a minikube. Moving on to the next insight. So here we can see that Neo4j as well. This is insights from Neo4j as well as Docker. So Neo4j is very useful for graph database, as we can see that we can easily see the relationship between different nodes, and it is very flexible to use. And sometimes if your database is well cleaned and well structured, then it takes a relationship automatically. And the graphical visualization makes it very easy to interpret the graph and understand our data set, which was bike cell, and which was very useful to comprehend our whole data, like how it is and what kind of it is, what kind of the data and the relationship between each other. The Docker allows applications to be packaged with all their dependencies, and it is very, as I earlier told that it is a portable container, and it can be installed and developed, and it is very useful for development and consistent and reliability based. So about talking the technical difficulties, it was very difficult to first establish our connection and load our main data set into Neo4j, and as well as creating pods and containerization. So compared to traditional relational database, it was quite difficult, but it was a way that we experienced how we can learn different tools in our like different ways. And the second technical difficulty was that we had to properly design our graph schema to and relationships can be critical to understand and can impact the performance and scalability of the database if the relationship is not well defined. And it was a little challenging to write the cipher when we were matching two or more nodes depending on their relationships. Yes, so that's it.
All right, thank you guys. So yeah, that was our walkthrough of MongoDB and Neo4j. We will leave the links to both the blogs in the description, so that if you want to go back there and walk through the steps and also view the images more clearly, that would be accessible. Those would be, again, the links would be in the description. And that's it for this video. Thank you.
Thank you.